Examine the functions below and fill out the chart using the symbols less than, greater than, or equal to compare the two and answer the questions after filling out this chart. Okay, so let's plug this in. Let's go second plus 712 and type in 3x squared, subtract 2x minus 5. So I can see that I have two x-intercepts. So the number of real x-intercepts, this is f of x, don't be confused here. So f of x has two x-intercepts. What is the smallest? So let's see here. So remember, second trace is 0. Press enter. You're going to come from the left, so left bound. A little high there. Right bound, and back to it. So negative 1, 0. And let's check the second one. Second trace 0. Below for left, above for right, back on top. And 1.6 repeating 0 is the second one. All right, so I'm filling out this information here. So the smallest of these two would be an x-intercept of negative 1. So negative 1, 0 is the smaller, and there's two real x-intercepts. Now to figure out the minimum, so I need to go between 0 and 2, between 0 and 2. So I can see from 0 to 2, noise level. Let's go from negative 1 to 3. So I'm looking from 0 to 2. What is the lowest point? I can see the lowest point from x is 0 to x is 2. This is an interval. X equals 0 and x equals 2. From here to here, what is the lowest point? It looks like it occurs at the minimum of this parabola. So let's figure out the minimum value. Second trace minimum. Left of the lowest, right of the lowest, and your lowest point. So what is the minimum value? This is, we're discussing a y value here. So y equals negative 5.3 repeating is your minimum value. Now rate of change, remember? Rate of change is referring to an x intervals here, so negative 1 and positive 1. Now let's figure out what y values go with this function. So second trace value, what goes with negative 1? The answer is 0. Second trace value, what goes with 1? Negative 4. x1, y1, x2, y2. So to figure out the rate of change over this specific interval, we're going to figure out the slope. y2 subtract y1 over x2 subtract x1. Negative 4 subtract 0 is negative 4. Two negatives make a positive. 1 plus 1 is 2. Your answer here, when divided, would be negative 2. Okay, now we figure these out by looking at our graph. So the number of x-intercepts is 1. What is the smallest x-intercept? Well, there's only one, and it occurs at 1, 2, 3, 4. So between negative 3 and negative 4, I'll approximate it. What is the minimum between 0 and 2? Well, here's 0, and here's 2. So in this range, what is the lowest? The lowest point is going to occur right there. And to me, that looks like it has a y value of maybe, approximation, 0.8. Rate of change. So negative 1 has a y value of 5, and positive 1 has a y value of 3. x1, y1, x sub 2, y sub 2. So we're doing the slope or the rate of change over this specific interval. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 3 minus 5 is negative 2. Two negatives make a positive. 1 plus 1 is 2. Reduces to negative 1. Now we fill them out. So 2 is greater than 1. Looking at these numbers, okay, negative 3.75 is the smaller. Remember when we're talking about inequality symbols, this point faces the smaller of the two numbers. This is the smaller one to the left, and this is the smaller one again to the left. How do the end behaviors of the two functions compare? as x goes to positive infinity. So for g of x, as you go to the far right, your function is headed up. So for g of x, as x goes to positive infinity, g of x also goes to positive infinity. For this graph, notice it's looking like this. If I pull this back out, you can see it. And as x goes to positive infinity, f of x is also headed to positive infinity. So we can see they have the same end behavior as x approaches positive, and I'm sorry for the messiness, infinity. So in both cases, as you go to the far right, both functions are headed up. Which equation has a smaller local minimum? Okay. Smaller local minimum. So we know that this y value is negative 5.3. And we know this was 0.8. So the smaller of the two would have been f of x. And that was actually, for both of them, been an absolute minimum.